Okay, here is video 4.5 on other methods of proving triangles congruent, and there are three objectives. So this one is the proof of the angle side theorem, but you remember we've been doing this without having this theorem. We changed this to angle side angle. You remember? So you can do this proof. Okay, so do this as a warm-up before we start. And once that's done, from now on, we can use angle side as a theorem. It's not a postulate. So remember, side, angle side, and angle side angle. These are all postulate, right? This one is a theorem. And we are going to learn another theorem called HL in this packet. And then we also do a lot of proofs about overlapping triangles, okay? So these three objectives are in 4.5, okay? So the first one is use the angle side theorem to prove two triangles congruent. And here is the word for the theorems. The hope you already proven on the warm-up page. Let's just refocus. Okay. If two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Okay. All right. So here is one example of the overlapping triangle. We're gonna do more examples later in this packet, but these are two overlapping triangles. You see that? Okay. Do you see overlapping triangles in the photograph? Sometimes you want to prove that certain overlapping triangles are congruent. For example, suppose you have a following problem. So GJ and GK are congruent, and H and L are congruent, and you want to prove that these triangles are congruent. So think for now, and I said using angle side theorem as a title. So that's for the theorem that you're using. So think about it and build the roadmap. Okay. And so do you have it? You see it? This is the angle that is shared, right? For the both triangle. So it's angle side, angle side. And you can prove the triangles congruent. So maybe I can write the statements for you. So GJ is congruent to GK, and two, you do the reasons, okay? So that's one side, so that's a side, and angle H is congruent to angle I, and that is angle. And then 3, angle G is congruent to angle G. Now there's only one angle here, so you can use just the G. But if you were to use the 3 alphabets, then it's angle HGJ is congruent to IGK. Maybe I write it that way, just to reinforce that point. You have to follow the corresponding order of alphabets. So HGJ is congruent to IGK, and that's an angle. Okay, so now you have 3 congruent statements. So you can say the triangle GJH is congruent to triangle GKI. Wait, GHJ, GIK. Okay, so let's just go that one with that order that it's asking you to do. So triangle GHJ is congruent to triangle GIK, and you're done. Okay, so you do the reasons. Okay. All right. So here is objective 3. Using the HL theorem to prove two right triangles congruent. So here is the keyword here. HL theorem only works for right triangles. Okay. Our final method of proving triangles congruent applies only to right triangles. In the right triangle, the side opposite the right angle is called hypotenuse. This is hypotenuse. This is right angle. Side opposite is hypotenuse. Hypotenuse is always the longest side of the triangle, because you remember in right triangle, 2 other angles are acute, right? So that means 90 degrees is the largest angle of the three. The side across the largest is the longest. Okay, the side across the most acute angle is the shortest, and so forth. Okay, and the other two are called legs. These are called legs. That's hypotenuse. So hypotenuse leg means, the HL theorem is a hypotenuse leg theorem. Okay, so if the hypotenuse and the leg of one triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. So here is triangle ABC and triangle DEF, and C and F are right angles, and AB and D, these are hypotenuse, they are congruent, and BC is congruent to EF, that's one of the legs, right? And you have to prove that these triangles are congruent. Now, as is right now, without any of these, that's side-side angle. You see that? That's a side-side angle, side-side angle. So side-side angle, you remember, it doesn't work, right? We said that that's one of the combination of side and angle that doesn't work. But it actually does work for right angles, for the right triangles. It only works for right triangles. It doesn't work for any other triangles. Okay? Actually, I think it does work for the obtuse triangle as long as the one of the side is that is the longest side. Yeah, but that you don't learn that in this textbook. So you just have to worry about this HL for right triangles only. Okay, so here is the way that it's been proven. I'm not asking you to write this proof. I just want you to understand it. By ruler postulate, there is a point G on the ray opposite to FD, so that FG is CA. So you draw a line here that is same length as AC to the other side. Because DEF is a right triangle, the angle GFE right here is also a right angle, and ABC is GEF by side angle side. Because the side is shared, these are congruent, right? So the side is shared, and that's a right angle, and then we made this the same length, so that by side angle side, these two triangles are congruent. Then AB is congruent to GE. So this length have to be congruent to this length. And since DE is AB, we have DE equal GE. DE equal GE in isosceles. So now this is isosceles triangle. So that means these angles are congruent. And since ABC is congruent to GEF, angle A is congruent to angle G. Angle A is congruent to angle G. Then angle A have to be congruent with angle D by transitive property. So now, finally, triangle ABC is congruent to DEF by angle side. Okay, you got the angle, and side. You see that it's kind of long, but so you don't have to produce a proof like this, but you understand why. That it's long proof, but we have proven, so now you can use the HL. If you know the triangles are both right angles, and you know the hypotenuse are congruent, and you know the one of the legs are congruent, then side-side angle turns into HL. Now, if you know that it's a right triangle, and then you know the two legs are congruent, that's side angle side, right? So that would work as well for a different theorem. If you don't know the two sides, but you know the one of the hypotenuse, then it's a side-side angle, but it works for right triangles. So in writing the proofs, you remember I told you to write A and S and so forth, okay? For the HL, what you have to write is first you have to say the both triangles are right triangles, okay? So then maybe you write next to the statement that you say R. Then next to the hypotenuse congruent statement you say H, and next to the leg statement you say L. Okay, but you still have to have a three statement. The one statement is that both triangles are right triangles, and hypotenuse are congruent, and legs are congruent. So you still have to have a three lines before you can say the triangles are congruent. Okay. All right. So here is a summary of the ways to prove two triangles congruent. You got these three that we learned already, these were in 4.3, right? Yeah. And this one just came out. This is in 4.5. And this one is also in 4.5. And then in 4.4, we did the isosceles triangle, right? So those are what we've done in chapter 4 so far. So here's the practice. State which congruent methods can you use to prove the triangle is congruent. If no method applies, say none. Okay? So I want you to do this one, this one, this one, this one, this one, and this one. Okay, do this homework. Okay, so far the homework is you have to write these reasons as well, right? Homework. Okay, and let's see here. It's objective 4. Prove that two overlapping triangles are congruent. Prove that two overlapping triangles are congruent. So those are these, and it can get a little bit complicated. For each diagram, name a pair of overlapping triangles. Tell whether the triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, or HL method. Okay, so I'm gonna do 10 and 12 in the video, and you guys do these two homework. But you don't have to write the proof, just to write yeah, tell whether the triangles are congruent by what. Okay, you don't have to write the proof. So it's kind of just a roadmap, and then identify the method. Okay, so AB is congruent to DC, and AC is congruent to DB. So these are congruent, and this is shared. So this will be side, side, side. You see that it's this triangle ABC is congruent to triangle DCB. Okay, 12. WU is congruent to ZB, so these are congruent, and WX is congruent to, so these are congruent. Okay, and then these are right angles. Okay, so these are right angles, and if these are congruent and this part is shared by 2, you remember we did this in like chapter 1 or 2, segment addition postulate proofs that if this side is angle addition postulate, this plus xy have to equal this plus xy, because xy is the same, and then wx is congruent to yz. So that's the you have to do those proofs. So you still have to do it. Remember, once you finish the chapter doesn't mean that we are done with that. So you have to be able to go back and be able to do it. So that means the WY is congruent to ZX. So that's the hypotenuse, and then the leg. So this is HL. HL theorem. This is postulate. You have to write the postulate theorem. Okay, so you do these two. And I think we are done with this packet. The rest is proof and problems. But you see how the diagrams get really tricky. This one, like last year, a lot of quality time was spent on these. These are fun problems. Okay, so we will probably spend 2 days on this packet as well. So if you wanna have a preview of some of these proofs, just to look at it, don't have to write it, just to look at it and see if you can come up with roadmaps. Okay, see you in class.